Hi friends, welcome to SS Maths Academy and welcome to 5th class of out of 36 classes. Welcome to 5th class. Today, dear children, I have to come with you eagerly. I am waiting to you explain about such a good topic in that order out of 14 chapter. The second chapter is, yes, you are guessing is correct. That is nothing but sets. Sets theory. What is the importance of sets? Yes, most probably all the competitive exams you remember set theorem. From the set theory we are getting minimum 2 questions, maximum 4 questions. We are expecting each and every year entrance exam. Am I right or not? And now A level, B level, C level, all the level students are very easy to understand this topic. They are very interesting to do these problems in this set theory. Just we have to give such a small concentration in this class, then you will write the answer without practicing in the exam. No doubt at all, I assure it. Now friends, I want to tell you, before going to explain the problems, I want to tell a clear cut information. Traditional method is important. Peddala mata saddi moota. That is a traditional word, it is fact. Right? Sadhanamlo panalu samakuru daralona. It is fact. Same the way concept is king. Concept is king. Content is power. I trust that word. I should explain that concept, that content. Then after we will go for model questions. Then after we will go for last previous year questions in shortcut way. Let us see, my dear children, come with your peaceful mind to the topic. Mind mapping. Yeah. This is a total preview of set movie. This is a one movie, multi-starrer movie. This is a total preview of you. If you know this total preview in your mind, dear boys, definitely you will get 4 by 4 marks. 2 questions will come, 2 by 2. 4 questions will come, 4 by 4. Definitely you will get full marks from the set without losing any mark. What is the concept, sir? I have to go with in order. What is set? Yes, set is I told you very clear. A set is a well-defined collection of objects. Sir, you are using one beautiful term from English. I am not saying English grammar. I am telling you the statement. Set is a well-defined collection of objects. Right? Group of words make a sentence. These meaningful words you see. A set is a well-defined collection of objects. Why it is well-defined? You might have a doubt. Friends, in this concept is this set theory is a comparatively new concept in mathematics. It was derived from mathematics. Ancient famous mathematician, the father of sets is nothing but Sir George Cantor. Who is father of sets? Sir George Cantor, famous ancient mathematician. He only developed the set theory in mathematics. A well-defined collection of objects is called set. What is the meaning? What is the use of well-defined word here? A collection of objects is also set? No. Why should we take well-defined? Means I want to tell you. Let us see. Here, well-defined, not well-defined. An object or elements or values or anything are the synonyms of the sets. You can take object, items, elements, values, whatever it is you can take that. That objects are belongs to in a set. It must have a common property or common feature. It must have a particular feature, particular definition. Then we can say that the particular things are called sets. It should be possible to decide whether the object is belong to set or not. For example, everybody can come to understand by taking the example. Virat Kohli is the best batsman in the world. It is clear. Is the person is there? We saw the matches. We decided it. Either wrong or right. Either true or false. It is fact. It is well defined. The top 5 batsmen in India. Write top 5 batsmen in India. It cannot be possible to write because in India only 5 top batsmen are there. Many are there. It is a huge batsmen are there. Top two talented writers in India. Nothing at all. Who is that? He is clever. Who is clever? She is beautiful. Who is she? Yes, Anushka Sharma is a beautiful actor. Anushka is the derived. Kohli is derived. But she is it. The most talented writers, best players in the world. We cannot describe. That particular word means well defined. We are not giving any particular, no, the particular definition, particular feature is not there, no. That is called not well defined, undefined terms. Undefined terms are not a set. Well defined terms, objects are called set. This is a set. That means the reason we are using the word a set is a well defined collection of objects. Remember, dear friends, a set is a dash object, well defined collection of objects. Remember. Now in set, the set can be denoted by capital letters of English alphabet. In that elements, in that object are denoted by small case letter in English alphabet. Remember, dear friends. And well defined after, we should go with the next presentation. Representation of sets. Yes, the sets should be represented in three ways. One is roster form, nothing but tabular form. Roster form also called as tabular form. Set-builder form also called as ruler form. Venn diagram. Venn diagrams also called as Venn-Euler diagrams. Venn-Euler diagrams. These are the ways we have to represent the sets in our topic, in our questions. Roster form or are called as tabular form, set-builder form, ruler form, Venn-Euler diagrams. Friends, after representation, how many types of sets are there in this concept? These are the main important concepts. Total 10 types of sets are there. Total 10 types. We should discuss about that. In that only we should frame a question. They will frame the question from this area. They will give in the exam. We have to write. We know the concept. We have to write the answer directly. Really, after seeing the concept, you will tell the answer. You will only tell the answer. Come to the practical proof. Now, basic operations: union of sets, intersection of sets, difference of sets. These are the things we are going to discuss today in our class. Then you have to get the full marks. Let us see first value. Friends, what is roster form? Yeah. For example, I want to write the vowels in the set. What are the vowels in English alphabet? A, E, I, O, U are called. These 5 letters belongs to vowel. In the sense we can write the vowel, the terms we can, the order is not mandatory here. You can write any order, but the letters should be separated by comma, enclosed by flower bracket or brace bracket. Then it is called, then this system, then the phenomena is called tabular form or a roster form. For example, A, E, I, O, U. The letters are separated by comma, enclosed by flower bracket, then this is called roster form. The set of elements, the set of numbers, the set of even numbers less than 10. Simple. 2, 4, 6, 8. These are the even numbers less than 10. You see, I separated the elements. The number of letters in the word Polytechnic, we have to write a set. For example, Polytechnic, Polycet, not Polytechnic. P O L Y C E T. This is called example of roster form as well as tabular form. Simple amma. The elements can be right separated by comma, enclosed by flower bracket. Then it is called set. We can represent a set capital letters. Your choice. Capital A, capital X, capital P. These are called example of tabular form as well as roster form. What about set builder form? Simple amma. In this method, in this representation, the elements can be represented by, the elements can be described by have a common property for each and every element. For example, yes, this is what children, 2, 4, 6, 8, 10. Even numbers up to 10. We can, this is a roster form. I should convert the roster form into the set builder form. What is the way I am doing here? Common property. Let us see. Shall I write like this? 2x such that x belongs to n, x less than or equals to 5 or x less than 6. Children, you remember 2x. Yes, I am taking common property 2x. Yes, such that. This is called as such that. This is also called as such that. This x is belongs to. You know the Greek letter, the Greek term belongs to. This is belongs to. For example, some x is belongs to A. We can represent it like this. X is belongs to A. Telangana and Andhra Pradesh are belongs to India. We can say like this, right? Maharashtra does not belongs to Telangana. Does not belongs to. -1 does not belongs to natural number. -1 is not there in natural number. We can represent it does not belongs to. It is there. We can say x belongs to. So that here x is belongs to natural number where x is up to 5, less than or equals to 5. It means x value you can take from up to 5. 0, 1, 2, 3, 4, 5. Don't take 0 because natural number 0 is not there. So 1, 2, 3, 4, 5. You substitute here in the place of x. 1, 2, 1 ja 2. Substitute here 2, 2 ja 4. There 2, 3 ja 6 there. Like that 2, 4 ja 2, 5 ja. So the roster form we have written into set builder form. It is satisfied. So this is called set builder form. Let us see one more good example. 1 by 4, 1 by 9, 1 by 16. This is a one set builder form because separated by comma. We have to convert into set builder form. Means I am taking here capital X is equals 1 by x square such that x belongs to natural number x less than or equals to 4. Completed. In the place of x, you can take values up to 4. 1, 2, 3, 4. 1 by 1 square 1. 1 by 2 square 4. 1 by 3 square 9. 1 by 4 square 16. You see the property is satisfied. Of course, it has many methods are there. We can write like this also. This is a set builder form. We can write another form also. How it is like this? You see better. X such that x belongs to n and x is a even number. X is a even number up to 10. This is also correct. Oh, set builder form we can represent two ways. Yes, two ways are there. X is what amma? Natural number. X is what amma? Up to even number up to 10 anda. 2 means 2, 4, 6, 8, 10 even numbers. This is also correct. Am I right or not, dear friends? Remember what I am saying. You have to observe very clearly. You listen carefully. Then you will get the answer. Nice. Yes. Venn diagrams. Set roster form is over. Set builder form concept is completed. Now Venn diagram. John Venn and Euler, these are the Switzerland English mathematicians. These two fellows, these two friends all developed one topic, one representation of sets. That is nothing but Venn Euler diagram. Simply we can say that Venn diagrams. Friends, Venn diagrams is the one of the way of we have to describe the relationship between the sets. Yeah, relationship between the sets. It is described. Then it is called Venn diagram. We should use now. While we are going to draw the Venn diagram, then you can understand unions, intersection, difference. In that time we are using circular shape. That is called Venn diagrams. Next, friends, types. Subset. Subset, superset, null set, equal set, equivalent set, finite set, infinite set, power set, order of the set, design set, universal set. 10 sets are there. What is subset? Types of sets. Here 10 types of sets are there. In the first one, what is subset? What is subset? Simple amma. If every element of A, if for example I am taking two sets, capital A and capital B, if every element of A is an element of B, then A is called subset of B. Then B is called superset of A. Once again, every element of A, taking one example, A equals to 1, 2, 3, B equals to 1, 2, 3, 4, 5. Every element of A, that those all the elements are in B, right? Then A is called subset of B, then B is called superset of A. Finish. These two close. One second. These three elements are there. So A will be there in A. So A will be there in B. So A is subset of B. It is denoted by A is subset B. A is subset B. Now B is called superset. Superset. Pedana, big brother. Superset. It is denoted by B is superset. Superset of A. B is superset of A. A is subset of B. This is the concept of subset and superset. Now the elements of A, that those elements in B, then A is called subset of B, B is called superset of B. Next, null set, or are called as void set, also called as empty set. These are the synonym of this word. Simple amma. A set which is does not have any element, then the set is called empty set. There is no element in that. One element there. For suppose somebody starts saying this is empty set. No, it is not empty set. It is a singleton set. Singleton set. One element will be there. Only one element will be there. That is singleton. Null set means which is does not have any element. Means, for example, x such that x belongs to n, natural number. The x lies between -1 to +5. X is a natural number. X is lies between -1 to +5. It is possible because natural number no negative elements. So it is empty. No, in this no elements, nothing at all. So it is denoted by pi. It is denoted by pi. Okay. Sometimes we can recognize like this. Right, my dear friends. Now finish. Okay. Now finite set, infinite set. Simple. A set consists countable elements. It is called finite set. Simple amma. If we count the elements, it is finite set. Set of oval numbers up to 10. Set of whole numbers up to 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We count it. Set of letters in the movie Bahubali. Yes, 5, 6 will be there. We should count it. Next, infinite set. A set is called infinite set. In this we are uncountable. We are not able to count the elements. Means the set having uncountable elements is called infinite set. Example, natural number, whole number, integer, rational, irrational, all the sets, and the set of even numbers, set of multiples of 2, multiples of 5. These are called example of finite and infinite. One more example, factors of 6. Finite set or infinite set, friends? Factors of 6. Sir, finite. Very good, because it is countable. 6 factors. 1 6 are 6. 2 3 are 6. 3 2 are 6. 6 1 are 6. How many factors? 1 2 3 6. 4 factors. Countable. Finite set. Multiples of 6. 6 1 are 6. 6 2 are 12. 6 10 are 60. No. The tables they decided up to 10. But many are their multiples. Infinite. So uncountable. That is called infinite set. Finite means countable. Infinite means uncountable. Next, equal set. A set is if two sets are said to be equal set, these two sets are having exactly equal elements. Exactly equal. Using my word, exactly equal weight. For example, A is having 1 2 3. B is having 2 3 1. Number of elements also same. These two are called equal sets. For example, a array is consisting Ram, Rahim, Robert. 3 persons are there. B set consists Rahim, Ram, Robert. In A, 3 persons are there. In B, 3 persons are there. Elements Ram, Rahim, Robert. Here also Rahim, Ram, Robert. Elements are same. Number of elements also same. That means exactly same elements. Number and that elements both are same. Then it is called equal set. Only elements, number of elements are same. A equals to 1, 2, 3, B equals to A, B, C. 3, 3 only same. Then that type of sets are called equivalent set. Equivalent set. Next, order or cardinal or number of elements of a set. Simple amount. Order of a set. Yes. Natural number. Here, what is the order of the set? 3. What is the order of set? This 5. What is the order of the set? 5. What is the order of the set? 5. What is the order of the set? 4. Means how many elements the set consists, that is called order of a set. This set consists of 3 elements. That is the reason order of set A, order of A is 3, or n of A equals to, also we can say that 3. This set consists 1, 2, 3, 4, 5. 5 elements. This set consists 1, 2, 3, 3. That is called order or cardinal number of a set. Overall number of elements of a set is called 3. Here 5. Like that we can say that. For example, set of natural number, its order undefined because the set does not exist. So the order will be possible to only finite sets only. Note, the order of the sets we should find only finite set. Infinite set cannot be described, cannot be defined. Now come to the point. Disjoint set. Simple amount. Disjoint pair. Joint. Disjoint. Joint. Disjoint. If two sets are said to be disjoint set, it does not have any common elements. If two sets are said to be disjoint set, if its intersection should be infinite. It does not have any common elements. How it is? Let us see one example. Here. A equals 1, 3, 5, 7, 9. What is that, my friends? You are smart. Odd numbers. Good. What about B? Even numbers. Good. Its intersection. This will belongs to intersection. Common elements. Common elements. I will tell you everything. I will tell you in the problem time. But I am telling you about concept beta. Concept. Remember, I told you concept is king. Content is power. So A intersection B. What is the common elements? In that both sets, what is the same element, same number? Not there. 1, 3, 5, 7, 9, 2, 4, 6, 8, 10. Nothing. So empty means pi. If A intersection B equals to pi, then the set is called disjoint set. Or if two sets are said to be disjoint, its A intersection B is pi. This is the answer. One question will come like this. If A intersection B equals to pi, then the sets are called as dash. Finite, infinite, disjoint, null. Disjoint set. Very good. Next, power set. The list of subsets we can write in the form of 2 to the power of n. A power set is power of set A. For example, I am taking here A 1, 3, 5, 7, 5 elements. Order of set is 5. The list of subset we can write 2 to the power of 5 means we can write 32 subset as a one big set. That is called power set. 1 second. Power set is nothing but the number of order of elements. It can be written as 2 to the power of n form. The number of elements should be 32. The number of 30 elements as a subset of a one big set, then it is called power set. Now by the example you can understand. Now, yes, I should ask one question, Amma. How many elements does have as a power set in this set? You can think here how many order of set is what? 3. What is the formula? 2 power of n. 2 power of 3. 2 power 3 means 2 into 2 into 3. 8. 8 subset. How many subsets will be there? 8. Answer will be 8. 4 will be there. 2 to the power of 4. 16. 5 will be there. 2 to the power of 5 means 30. Like that we can say the answer. They are not asking lengthy answer. They are asking them how many proper subset this set is consists. That's it. Next. Now last one but not least one, universal set. A set which consists all the subset under consideration, then the big set is called universal set. It is denoted by capital U or mu or sigma, all like this. These are the notation of universal set. Universal set we can represent in rectangles. All the universal set we can represent in rectangles. For suppose here natural number, whole number, like this we can say that here universal set. It is represented in rectangles. Now friends, these are the types of sets are completed. Representation of sets completed. Now let us go with one last topic. Yes, basic operation, union, intersection, difference. After these 2 minutes, we will start our model questions. Let us see. Friends, last topic, basic operation on sets. You see, how many basic operations are there? Simple. Up to 10th standard I am saying. In intermediate many are there. For about our polyset, what is the use of polyset? I am telling that union of sets, intersection of sets, difference of sets. Let us see here union. Union of set. What is the meaning of union? Many unions are there. Unions means we should join with everybody. We should mingle with anyone. That is called union. The general concept of our daily life. In here, A union of B, A union of B. We can A union B means A union of B means we can say that the number of elements of A and B, its union should be. We can say that the elements in A or the elements in B are both. For example, here A equals to 1, 2, 3, B equals to 1, 2, 3, 4, 5. Here many formulas we should describe it also. Here A union B means that the number of elements will be in A or will be in B or in both. Means the elements are in A or in B or in both. Means A union B nothing but you should write in order. This is called A union B. The number of elements in 1, 2, 3 are in A or 1, 2, 3, 4, 5 are in B and both. Sometimes we can say that A equals to 1, 2, 3, here B is equals to null set. What is A union B? Simple. A union B is nothing but 1, 2, 3 only. Because the elements either in A or B, we can write as a union. Here in this B is not their elements, but A union B is possible. Means A elements are 1, 2, 3 also. Right, my dear friends? Remember. So A union B we can read as A union B. We can denote it by A reverse A union U symbol and B. Now this is called general representation. Now basic operation union we can say that simple amount. A union B means the shaded part. This is called A union B. Here this is called universal set. Universal sets are denoted by rectangles. Universal sets are denoted by rectangles. We can note it as union. Right? Now intersection. I told you very clearly. Intersection of two sets. The elements are in both A and B, but common elements only we should take it out and write in a set. That is called intersection. For example, A is 1, 2, 3, B is 1, 2, 3, 4, 5. What about it is intersection? I told you both sets are having common elements. Pick it. What are the common elements? 1, 1, 2, 2, 3, 3. Then you can write in this. This is called A intersection B. Oh, A union B means the elements will be in A or not in B also we can write A union B. But in intersection, the elements must be there in both sets like that. For suppose A is having 1, 2, 3, B is having empty set. What about its A intersection B, dear friends? You should guess it. 1, 2, 3. No, pi only. Nothing elements. Because the definition of A intersection B means common elements we should pick it. Here 1, 2, 3 is there, here no elements. So we should not take any common elements picked out. So that is the reason we are getting pi. These phenomena I should show in Venn diagrams. A is B is having no common elements. Okay, na? Remember, I am showing the A intersection B as in Venn diagrams. Let us see the middle part, only the middle part. This is shaded part is called A intersection B. Okay, notated by A reverse U B. It is noted by A U B. We can for our convenience we can read as A union B. This is A intersection B. Now third basic operation is difference. A minus B difference. B minus A difference. Simple amount. Means if two sets are having some elements, We have to cut the values. Those the sets are having common elements, we have to cut it. First set which is having that elements is called a minus b. Once again I should say, a minus b is nothing but if two sets are having some elements, in these two sets what are the common elements, you have to remove it. The remaining elements from first set, that is called a minus b. The remaining elements for in second set, that is called b minus a. By the example you can understand. Here a equals to 1, 2, 3, b equals to 1, 2, 3, 4, 5. I am going to write first a minus b, dear friends. I told you, no? I told you, no? A minus b. A is having 1, 2, 3. Minus b is having 1, 2, 3, 4, 5. What are the common elements? 1, 1, 2, 2, 3, 3. What are the elements? First set is having nothing. Answer is 5. Here 4, 5 will be there. You don't take as an answer. You leave it. This set only we should take because a is first. But suppose here a is having one element extra, 6 will be there. First suppose. What is the answer? A minus b equals 6. Only single element will be available. Now what about b minus a? Same phenomena we should apply. B 1, 2, 3, 4, 5. Right now 1, 2, 3, 4, 5 minus a 1, 2, 3. Common elements, take it. 1, 1 cancel, 2, 2 cancel, 3, 3 cancel. First element, first set A, first set B. First set B is having two elements. That is answer is 4, 5. Finish. This is a concept. Just I am telling concept. When the problems will start, you might be understand. No doubt at all. Right? Here answer is 4, 5. Here answer like that. Okay? With Venn diagrams, I should draw it. Here the elements from only A. Here elements from only B. Here elements from only A part only share it. This is the answer of A minus B because B is there. This is B. We should not take the value from B. That is the reason we should not shade this part. Even though A is there here. A is there here. But the A will be there in B. So that is the reason we should not take it. This is A minus B. Now B minus A, simple. You shade only B. Okay? Clear. Now, very important question, symmetric difference of two sets A and B. That is nothing but notated by A delta B. We can read as A is symmetric difference of B. A delta B we can note it as A union B and A intersection B. It's a difference also called as A delta B. A delta B, A minus B or union B minus A also correct, or A and B, A intersection B, it's a difference also nothing but A delta B, delta B. How can we represent this one? Simple. A union B minus A intersection B means like this. Only shaded for A, only shaded for, leave the intersection position. You have to leave the middle position. Only middle part is called, this is called A intersection B. You are doing here A minus B or B minus A, nothing but only A, only B. This is leave it. This is the symbol, this is the showing part of Venn diagrams of the symmetric difference of A delta B. So friends, most probably 90% information I covered here, and one more complementary of a set A. Simple complementary of set A denoted by A to the power of C or A dash. Simple. A set is subtracted from universal set, then it is called complementary of given set. For example, universal set A is subtracted. For example, U equals universal set equals to 1, 2, 3 and so on 9, 10 up to 10. A equals first suppose 1, 2, 3. It's A dash or A power C. Complementary of set A is nothing but universal, which is subtracted from a universal set. Yes, subtracted. 1, 2, 3, 1, 2, 3 get cancelled. What is the remaining elements? 4, 5, 6 and so on 9, 10. This is the answer of complementary of set A. That's it. This is called complementary setup. And one formula is there. N of A union B is equals N of A plus N of B minus N of A intersection B. N of A intersection B. This is a beautiful formula. N of A, number of elements in A intersection A union B is equals N of A plus N of B minus N of A intersection B. These are the terms we are using to solve the many kind of questions. Friends, I told you very clear. Minimum past 5-10 years paper I observed it in that They are giving what we discuss in this concept only. They are covering the questions. Intersection means basic operations. Intersection, union, difference. One question they are giving. Types of sets. They are giving one question. Okay. From the Venn diagram, they are giving one question. Right. So already we covered basic operation, representation, types. These three concepts they are covered in the examination. They are making a question. They are giving the entrance exam. Then we should have to write the exam happily. So let us see. You have to solve the good question, good models I should explain.